So dear students, so how are you preparing well for your examinations for JEE mains? So yesterday we have in our class we discussed some problems from permutations and combinations. I hope that you understand those solutions. Okay. So in today's class we will discuss some more problems from permutations and combinations. So shall we start our class today? So let us see the today's problems. So dear students, welcome to our today's class. Okay, in our today's class, the first problem is the total number of two-digit odd numbers n such that 3 power n plus 7 power n is a multiple of 10. That means you have to find out here 7 odd numbers. That two-digit odd numbers. What are the two-digit odd numbers? 11, 13, 17, like that, so on up to 99. You have to select those two-digit odd numbers such that this sum is a multiple of 10. That means this should be either 10 or 20 or 30 or 50, so on. Understand? So to do this problem, you should know the one basic concept. What is that basic concept is? A power n plus b power n is a multiple of 10. Sorry, a power n plus b power n is a multiple of a plus b when n is odd number. When n is odd number. That means what? For example, let us take n is equal to 1. Let us take n is equal to 1. A power 1 plus b power 1 is a multiple of a plus b. Write it wrong? Yes. A plus b is divisible by a plus b. If let n is equal to 3, a cube plus b cube is a multiple of a plus b or not? Yes, it is a multiple. How can you say that? Yes, a cube plus b cube is divisible by a plus b. How can you say that? A cube plus b cube formula? A plus b into a square minus ab plus b square whole divided by a plus b. A plus b will be gets cancelled. Okay, now if n is a odd number, then only a power n plus b power n is a multiple of a plus b. Okay, I hope that you understand this concept. Now using this concept, we are going to solve this problem. Okay, so let us see the main solution. So dear students, coming to our main problem. So this is our main problem. The total number of two-digit odd numbers n such that 3 power n plus 7 power n is a multiple of 10. So the question is very clear. You have to find out the n values. That should be two-digit numbers, two-digit odd numbers. That may be you can start with 11 or maybe 13 or maybe 15, so that if you substitute here and you calculate the value, that should be a multiple of 10. What are the multiples of 10? The multiples of 10 are 10, 20, 30, 40, 50, like that. You should get the answer. But manually if you do that, the problem is become very difficult. Now we will use the concept which I discussed previously. So previously what I discussed, a power n plus b power n by a plus b. So a power n plus b power n is a divisible by a plus b, is a multiple of a plus b when n is odd number. Okay, now we will coming to our main problem. So this is 3 power n plus 7 power n is a multiple of 10 means what? It should be divisible by 10. It is divisible by 10. Okay, now. So can I write down it as a 3 power n plus 7 power n by 10? Can I write down 3 plus 7? Can I write it as a 3 plus 7? Right. Observe that both concepts are same or not? In place of a 3 is there, in place of b 7 is there. So 3 power 7 plus 7 power 7 is divisible by 3 plus 7 when n is odd number. When n is odd number. Clear. It is very clear. N is odd number. But he is asking 2-digit odd numbers. 2-digit. First of all, what are the odd numbers? 2-digit numbers 11, 12, 13, so on 99. They are 2-digit odd numbers. 2-digit numbers. From this we have to select odd numbers. So what are the odd numbers? 11, 13, 15, so on 99. They are the odd numbers. Clear? So we have to count all these numbers. So no need to feel any difficulty. So if you observe all these numbers, they are in arithmetic progression. With the first term is 11, common difference is 2. Okay now. So let us take, we know that last term 99 is equal to formula a plus n minus 1 into d. Okay now. So this is a 99 is equal to first term is 11, n we don't know, the common difference is 2. Clearly, so if you bring the 11 to left hand side, so 99 minus 11, 88 is equal to n minus 1 into 2. Okay now, so if you divide with the 2, so you will get how much? N minus 1 is equal to 44, n is equal to 45. So how many 2-digit numbers you are getting such that 3 power n plus 7 power n is a multiple of 10. How many numbers you will get? 45 numbers you will get. So our answer is answer B, 45. Okay. I hope that you understand this solution. So let us go for next problem. So dear students, welcome to our class. So now today's second problem is the number of 7-digit integers, with sum of the digits equal to 10. So there should be 7-digit number should be there. In that 7-digit, if you all add all the digits, that sum should be 10. And formed using the digits only 1, 2 and 3. That 7-digit number should be formed with only 1, 2, 3. So that the repetition is allowed. You can repeat. Obviously, repetition should be there. So 1, 2, 3 only how to use. That number should be a 7-digit number. If we add all the digits, the sum should be 10. The question is very, very, very clear. Question is very clear. Understand? So to solve this problem, in permutations, we have a basic concept. In permutations, we have some basic concept. What is that concept is? There are some n objects are there. There are n objects are there in which r objects are identical. Same. Total n objects are there. In that n objects, r objects are identical. Identical means same. They are same. Just like in our school, we have twin students. Twins we have. Triplets. That means all the 2 students are like that students are there. So they can be arranged number of arrangements. Here arrangements means linear arrangements is given by the formula n factorial by r factorial. Understand? So once again I am telling. So there are n objects are there. In that n objects, r objects are identical. Identical means same. So they can be arranged in a linear form. The number of arrangements is given by the formula n factorial by r factorial. So this is the basic concept that we are going to use to solve this problem. So let us see our solution for main problem. So dear students, coming to our main solution for this problem. Okay now. So first of all, there should be a 7-digit number. 1, 2, 3, 4, 5, 6, 7-digit number. There should be 7-digit number. That restriction is the first restriction is you have to use the digits 1, 2, 3 only. You have to use the digits 1, 2, 3 only. And moreover, if you add all the digits, the sum should be 10. The sum should be 10. That is the condition. So, this is a question asked in JEE Mains 2021. See how to think this problem, how to solve this problem. Okay, we will see various possibilities. Various possibilities we will see. So, in the first case, I will take 3 here, 3 here. Okay, first digit I will take 3. If I take 3 here, again 3 here, 3 plus 3 here, how much? 6. That means out of the sum 10, 6 is gone here. If I put 1, 1, 1, 1, 1, 5 ones are 5. Here this is 6 plus 5, you are getting the sum 11. So, that was you should not use the number 3 here. Let us take 2 here. Okay, now this is 2. So, here I can use 1, 1, 1, 1, 1. You see the sum? You see the sum? 3 plus 2, 10, 11, 12, sorry, 3 plus 2, 5, 6, 7, 8, 9, 10. 10 you are getting or not? Yes. So, this is one combination. This one combination. Okay. How many this type of arrangements are? That means you can use 3 here, 2 here, 1 here, 1 here, 1 here like that. You can use 3 here, 2 here, 1, 1, 1, 1 like this. So, this type of arrangements, how many you are getting? Total how many are here? 1, 2, 3, 4, 5, 6, 7 are there. That is 7 factorial by 7 factorial. How many identical are there? Identical numbers are there? 1, 2, 3, 4, 5. 5 factorial. So, 7 factorial by 5 factorial is given by the value 42. That is 7 into 6 into 5 factorial. 5 factorial will get cancelled. 7, 6 are 42. That means using this type of 3, 2, 1 in this pattern, how many you can get? How many you are getting? 42 arrangements you are getting. Let us take the another combination. Right. So, this is 1, 2, 3, 4, 5, 6, 7. Okay, now. So, you are using 7 digits. 1, 2, 3, 4, 5, 6, 7. Okay, now. Right. Now, here he is saying digits 1, 2 and 3 only. He is saying it is not compulsory. You have to use all the 3 at a time. All the 3. No need. No need. He is not saying compulsory. So, you may use or may not use, but if you have to use only 1, 2, 3. Okay, now. So, let us take another combination. So, already 3 over. Next to you, if you put another 3, you are not getting. You start with 2. You start with 2. So, if I put 1, 1, 1, 1, 1, 1 here, 2 plus this 6, 6 plus 2, 8 you are getting. So, there is a possibility of getting one more 2. Yes. Again, there is a possibility of 2 plus 2, and then if you can put 2 also, nothing wrong in it. 2 plus 2 plus 2, how much is 6? 6 here, 1, 1, 1, 1. 1, 1, 1, 1. See here, 2 plus 2, 4, 4 plus 2, 6. 7, 8, 9, 10. Some is are getting 10 or not. Yes, this is also one arrangement. This can be, that means what? You can put 2 here, you can put 2 here, 2 here, 1 here, 1 here, like that. This type of combinations. How many arrangements you will get? How many arrangements you will get? So, total number is 7 factorial. Total items are 7 factorial. In this, 2 is repeated identical. Here also ones are also identical. So, these 2, how many times it is repeated? It is repeated 3 times. That is why 3 factorial divided by 3 factorial into 1 is divided in how many times? 4 times it is divided. So, this is 4 factorial. If you calculate, its value is 35. Right. 7 factorial can be written as 7 into 6 into 4 into some 7 into 6 into 4 into 3 factorial. 3 factorial, 3 factorial is also cancelled. After calculating, you will get the value 35. So, therefore, total number of numbers is equal to how much? This is 42 plus 35. This is equal to 77. 42 plus 35, 77. So, you will get 77 numbers, as you have to use only be remember that here he is using the digits 1, 2 and 3 is not saying compulsorily you have to use 1, 2, 3. If it is compulsory, this possibility only will come. So you are not restricting anything. So another possibility you cannot get. So you try to do this with the 1, 2 remaining all ones. No, you cannot get. So our answer is 77. I hope that you understand this solution. So let us move to next problem. So dear students, welcome to our third problem in this session, right? First I will read the problem, try to understand the problem. A natural number has prime factorization given by n is equal to 2 power x into 3 power y into 5 power z. So there is a natural number, it has a prime factorization where y and z are such that y plus z is equal to 5 and y inverse plus z inverse is equal to 5 by 6 and y greater than z. Then the number of odd divisors of n, see here, the number of odd divisors of n including 1 is also is treated as a odd number including 1. So first try to understand this problem. First of all, total number of odd divisors he is asking. Okay, total number of divisors, from that we will get odd divisors. To do this problem, you should know one basic concept. Understand? Okay, first I will explain that basic concept. Okay, so what is the basic concept is any number, natural number n, except any number n, if you are expressed in as a product of prime factors, that is 2 power x into 3 power y into 5 power z into 5 power z into next prime number is sub 7 power l, so like that, so it like that. So the total number of divisors of n, total number of divisors of n is given by, so here in the, see here 2, 3, 5, 7, they are all prime numbers. What are their powers? X, y, z, l, so on. So therefore the total number of divisors of n is given by the formula x plus 1 into y plus 1 into z plus 1 into l plus 1 into so on. This is the main formula to solve this problem. Understand? So using this formula, so we are going to solve this problem. So let us see the main solution. So dear students, welcome to our main solution. So here n is given by n is equal to 2 power x into 3 power y into 5 power z. So it did not given any information regarding x, is given only the information regarding y and z. So here clearly y plus z is equal to how much? 5. Y plus z is equal to 5. Here y inverse plus z inverse is equal to 5 by 6. So let us solve this problem. Let us solve this y and z value. So here clearly y plus z is equal to 5. So this is y inverse means 1 by y plus 1 by z is equal to 5 by 6. Okay now. So this is given by, if you take a LCM, y plus z by yz is equal to 5 by 6. Clear? Here y plus z value is how much? 5. Y plus z value is how much? 5. So this value is 5. So therefore you can get 5 get cancelled. Yz is equal to 6. Yz is equal to 6. Y plus z is equal to 5. And moreover, y greater than z. You can easily guess the answer. Two numbers, their sum should be 5 and their product should be 6. What are the two numbers? Clearly 2 and 3. See here, easily you can say 2 plus 3 how much? 5. 2 3s are 6. No need to solve. It's a very easy one. So he is saying y greater than z. So this value should be y, this value should be z. Clearly that is also given y greater than z. So the big value is y, smaller value is z. Therefore, your problem will become n is equal to 2 power x, we don't know, 3 power y value is 3 into 5 power z value is 2. Very clear, very clear. Up to that, if it is given directly, actually nothing is in here. So he is given some information about y and z, so easily we can solve it, y and z values. Now coming to here, once again we will read the problem. Then the number of odd divisors of n, odd divisors of n, he is asking odd divisors. See here, in our natural theory of numbers, we have a very easy concept. First of all, take one even number, for example 12. 12 is the even number. Tell me the divisors of 12. Tell me the divisors of 12. What are the divisors of 12? 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. All are divisors of 12. If you observe, in this there are some even numbers are there, some odd numbers are also there. Even numbers are also there, odd numbers are also there. Let us take an odd number. Let us take a odd number. Let us take any odd number, some 27. 27 is an odd number. So tell me what are the divisors of 27? Right, clearly 1, 3, 9, 27. 1, 3, 9, 27. If you observe, all are odd numbers. All are odd numbers. That means for an even number, the divisors are maybe all positive, maybe all negative, some positive, some even, some odd, whatever that. If it is an odd number is there, all divisors are odd numbers. All divisors are odd numbers. Now then the number of odd divisors of n, he is saying. Odd divisors of n means what? This should be odd number. This should be odd number. This can be odd number. This should be odd number. You want odd divisors. He is asking odd divisors. All odd divisors means this should be odd number. This can be odd number when it is possible. So 3 square 9, 5 square 25, 9 5 25, 45 you will get. This is up to here you will get odd number only. The only thing is lies here. For example, if you put 2 power 1, this is 2. If you multiply with the 2, it will become even number. If you put x plus 2, if you put x is equal to 2, 2 square 4, then it will become a even number. This will become odd number when x is equal to 0. When x is equal to 0. Then only it will become a odd number. Clear? So therefore, n is equal to 2 power 0, 3 cube, 5 square. Okay? 2 power 0, 3 cube, 5 square. So previously I explained one concept. So that is what are the number of divisors of n. So this is an odd number. Clearly it is an odd number. 2 power 0 is 1, 3 cube is 27, 5 square is 25. 27 into 25 if you multiply, surely you will get an odd number. So definitely n will get odd divisors only. N will get odd divisors only since this number is an odd number. So total number of divisors are how many? So as usual I told the formula. So in place of x, how much is there? 0. 0 plus 1 into 3 is there. 3 plus 1 into 2 is there. 2 plus 1. So total how much? 0 plus 1, 1, 3 plus 1, 4, 2 plus 1, 3. So 4 3s are 12. So how many odd divisors you will get? You will get 12 odd divisors. So the question is very, very clear. So here, so this n should have odd divisors. N will have odd divisors when this number is odd number. This will become odd number clearly x is equal to 0. Clearly, if x is equal to 0, therefore 2 power 0 is equal to 1, then only it will become odd number. Clear? Here y and z value he has given in two equations. I solved these two equations. I got y and z values. Such a easy concept you are using here. Nothing is used here. No intermediate concept here. Basic foundation concept only we are using here to solve this problem. Okay. I hope that you understand this solution very clearly. So today's all the three problems you are understand. I clearly explained. So if you have any solutions, any problems regarding, you can comment, and I will try to solve those problems. Okay. I hope that you enjoyed today's class. So let us see few more problems in the tomorrow's class. Okay. Thank you very much.